Okay, so today we're going to use Newton's law of cooling to solve this problem. First, we will find the value of the constant K. So we're going to start off by writing down the formula. So the temperature started being recorded since 4 p.m. and 1 hour later the temperature was 75. So we're going to use this data, which interprets into the time equaling 1. So we're going to begin with 75 equals 70, which is the ambient temperature, plus 80, which is the body's initial temperature, minus 70 times E with the exponent of negative K. And as I said before, since T is 1, we can disregard it from the problem. So we're going to start off by subtracting 80 minus 70, which gives us 10. Then we're going to subtract 70, which gives us 5, equals to 10 e to negative k. We're then going to divide 10 to both sides to isolate the e, which gives us 1/2 equals e to the negative k. Then we're going to use the natural log in order to cancel out the e. So it'll be ln of 1/2 equaling negative k. And since we don't want k to be a negative, we'll divide by -1 to both sides, which ends up being negative natural log of 1/2 equal k. Okay, so now we will try to find the elapsed time from death to the time of discovery. The time of discovery is 4 p.m. with a body temperature of 80, while the average body temperature is 98.6. We will use this data in our formula to find T. So 80, which is the body temperature at 4 p.m., equals 70 plus 98.6, which is the average body temperature when being alive, minus 70 times E to negative KT. So now we're going to subtract 98.6 minus 70, which gives us 28.6 e to negative kt. Then we're going to subtract 70 to each side, which gives us 10 equals to 28.6 e to negative kt. Then we're going to divide 28.6 to leave e by itself, which translates into 0.349 equals e. Then we're going to use the natural log to isolate e, which is going to be ln 0.349 equals negative 0.693, because we had already discovered the temperature, or we had already discovered the amount for K. So we're going to solve this part of the equation, which is ln times 0.49, which gives us negative 1.053 equals negative t. Like I said before, we're going to divide this. So divide by negative 0.693, then leaving us with t equals 1.519. Okay, so we now know that 1.5 hours elapsed since the time of death. So I'll just go ahead and write that down. And we found the body at 4 p.m. This means that Professor Fies died 1 hour and a half previous to 4 p.m. which is 2:30. Thus, the time of death is 2:30 p.m.